Alright, here we go. Domain and range. Alright, today, whenever I talk about domain, I'm going to use the color orange. Excuse me. So if you'd like to use a highlighter, you can. If you'd like to use a colored pencil, if you want to use a different color than orange because you hate orange, that's okay. Just use the same color for all your domain. Alright, and domain is a list of input values. Which, when we talk about a function, what part is the input values? The x. Good. I'll zoom in here. Sorry, I didn't know it was so zoomed out. Let me put my glasses on. There we go. Alright, domain. And then we have our range. And anytime I talk about range today, I'm going to use blue. If you'd like to use a different color, that's fine. You can use a highlighter. You can use a colored pencil. And range is a list of output values. What is the output values in a function? Y. Good. Now, when we make these lists, there's a couple of rules to make sure that we all are listing our lists in the same list. No? No, I thought that was funny? Okay. Make sure that all of our answers look relatively the same. So our two rules are that we are going to go least to greatest. And no repeats. If you need some cue words in there, what does least mean? Or what's another way to say least to greatest? Smallest to biggest. If you need those words in there to remind yourself small to big, you can. If you're like, yep, I got it, don't write that. That's fine. Your choice. All right, we have two examples that we're going to do first, and then we're going to talk a little bit about graphs and how domain and range on a graph we read a little bit different. So first we're going to do this with a set of ordered pairs. Remember when we do a set of ordered pairs, we worked with this yesterday, we use that like fancy squiggle. Look at that fancy squiggle. So fancy. I don't really like you. Just kidding. I do like you. Alright. The fancy squiggle is just to help read my hair. It's not a parenthesis. We just want to make it look different than the others. So our first ordered pair we have is 3, 4. Then we have 2, negative 6. Five, 2. And 3, 2. So this is a relationship. It has inputs and outputs. Is function. Does every input have exactly one output? No. Which input has more than one output? 3. Good, the 3. Because I go 3, when I put in 3, sometimes I get out 4. But a different time when I put in 3, I got out 2. I don't like having those two different answers there. So this is not a function. That's okay for today, but just to remind yourself. Alright, so we're going to find our domain and our range. Alright, when I look at domain, domain is what part of an ordered pair? The x's. So I'm going to put an x there to remind myself. Domain is x. So in my ordered pairs, which ones are my x's?
3, 2, 5.
The 3, 2, 5, and 3. Those are all the x's. I'm going to just start by just listing them in order. 3, 2, 5, 3. And then I can have the ordered pairs. The y, the output, good. So which ones are my y's?
2.
Okay. Again, I'm just going to list those to start off with. So 4, -6, 2, and 2. But before I finalize my answer, I want to make this list now least to greatest with no repeats. And because we're making a list, guess what we get to use? Fancy brackets. Alright, what is my least x? What was the smallest x we used? 2. And then what? 3. And even though I see 3 2 times, I'm only going to use it once. So 3 and then 5. Okay, if you're like, why don't we list that 3 more than once? It's kind of like taking a survey. If a teacher came and asked me, if my principal said, okay, what are the favorite colors in your room? Would I say, oh, well, like there was a red, a blue, a red, a blue, an orange, a blue, a red, a pink, a purple? Or red, blue, pink, and purple, and orange. Yeah, I wouldn't list them all the amount of times. I would just tell them what are the favorite colors. Okay, so we're just looking at what are the inputs. 2, 3, and 5. All right, now for our range, same idea. We're going to go least to greatest. So what is our least number here? -6. Negatives are always smaller than positives. So we're going to start with -6. Did you get a pass? -6, and then what? 2, and then 4. Okay, so those are actually our domain is that 2, 3, 5, and our range is that -6, 2, 4. For a table, we have an input and we have an output. This table is going to be vertical, so our x is going to be on the left side, and our y is going to be on the right side. We're going to have 5 lines. 3, 4, 5. Alright, so for our first ordered pair, we have 3, -7. Then when we put in 1, we get out a 5. When you put in a 0, we get out -3. We'd put in 4, we get out 5. And we put in -2, and we get out 9. Is this one a function? Does every input have exactly one output?
Yeah.
Where is there a repeat, though?
The y is with the 5.
Yeah, the y's. There's outputs. Is it okay to have an output repeat, though?
Yes.
Yeah, we just can have an input repeat. So our inputs, they all only have one answer, so we're good to go. So we're going to find our domain, and we're going to find our range. And with the table, it's a little bit easier. When we did those ordered pairs, each x and y were kind of paired together, and we had to like kind of pick out where our x's, where are the y's. Go so quick, Dorian. I don't want you to miss the graph part, okay? All right, so for our domain, we're going to look at which part? X. So I'm going to take a look at this left side, and it's all already there for me. I'm just going to need to order it least to greatest, no repeats. And for my range, I'm going to look at, which is all the right side. I just need to figure out how to order it least to greatest with no repeats. Alright, so for my domain, I'm going to list least to greatest. That way it's just nice and organized for whoever's reading this. What is my least x? -2. Good, 0. I'm going to put little dots next to them so I know I did them. So -2, 0, 1, 3, and 4. Alright, so now for my range. I want to think least. Remember least, if it's a negative, how do I know which negative is least? Yeah, it's the one that has the most amount of negatives. So what's my most amount of negatives in the y's? -7, good. Sometimes that can get us goofed up. So -7, -3, 5. Good. We only list that 5 once, and then that 9. Good. All right, we're going to write one more little description here, and then we'll have a glue in with a couple examples with our graphs. All right, so if you want to star this or put like an arrow next to it, somehow make it look like it's important. You could do even like a little squiggle to show off that this is kind of the same but kind of different. It's your choice. All right, this time we're going to be talking about graphs. And our domain and range on a graph is similar, but we just have to read it a little bit different because it's not listed out for us, and it's going to be listed out for us using that X and Y axis. So for our domain is our inputs. And on a graph, what represents the inputs? The x-axis. Good. So our domain, the x-axis. And what we're going to be looking for is, does it keep going left, left, left? Or right, right, right? You're going to hear that a lot in just a moment. Right now you're like, why is she saying it so many times? We're going to think left, 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 right, right, right. And remember, left and right means left and right, because that's our x-axis. Should have asked that as a question, but I didn't. Whoops. Teacher mistake. Okay, so our domain is the x-axis, and we're going to keep thinking to ourselves, does that graph go all the way to the left? Does it go all the way to the right? And then we have our range, and our range has to do with outputs. And what are our outputs going to be on a graph? It's going to be represented on the y-axis. Good. And which direction does the y-axis run? Up and down. So we're going to ask ourselves, does it keep going up, 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 or does it keep going down, down, down? And again, right now you guys are like, what the heck is she talking about? It'll make more sense as we do a problem, promise. All right, you're going to get a glue in. This glue in you should not need to cut apart. You do not need to cut it. You should be able to just glue it in. You want a couple rows underneath it. And so I would make sure that you have a couple rows at the bottom of this page. If you don't have a couple rows at the bottom of the page, you might need to glue the next page because we're going to write our answers right below this. So if you don't have space to write below it or next to it, maybe glue it on the next page. But you're just gluing it in right there. No cutting. When you glue it in, make sure you got that U in the right direction. You want that U facing up. Nice parabola. Can I write you a pass? I can after we're done with notes. Sorry, I didn't. Alright, so make sure that U is facing up. It should go the U, and then that curve, and then the line. Otherwise, you're going to have it upside down, and everything will be confusing in your life because nothing is the right way. Just kidding. Even if your math is upside down, it's okay. You'll live. Okay, so again, when you glue that in, you're going to want a couple lines underneath it to show our answers. If you don't have lines on it, maybe you glue it on the next page. So we're going to write our answers right underneath. Give you about 30 more seconds to get that glued in. What? What? Never mind. Okay. All right. So for this first one here, we're going to look at our domain and our range. So domain is our x-axis. So I'm going to actually take my orange color here and I'm going to highlight that x-axis going left to right. And that's going to represent my domain. So I'm just going to do D for domain because we're going to run out of space if we write out the whole thing. And my range is going to go with that y-axis, that up and down. So as I look at my graph, I'm going to zoom in pretty close here. If you're missing out on some notes, you'll have to just grab them later. Zoom in on this problem with us. Alright, so as we follow this parabola, with domain, I want to be thinking left, 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 and right, right, right. So if I follow this parabola to the left, does this keep going left, 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 left forever and always? Yeah. Well, how do I know it's going to keep going left, left, left forever and always? Good. The arrow at the end going to the left. What about to the right? Will it keep going to the right, 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 right?
Yes.
Yeah. Is there any beginning or ending to it?
No.
No, it goes in both directions. So because it keeps going on and on and on and on and on forever and ever and ever and ever, always and always, always, from the day that you were born to the day that you die, it keeps going on and on and on and on and on and on and on, we say all real numbers. Sorry, I didn't mean to bring death into it. Sometimes I just have to make sure you're paying attention. Alright, so it goes over all the x's because it keeps going to the left and it keeps going to the right. Now for a range, I'm going to think up and down. I'm looking at my y. So does this keep going up, 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 up?
Yes.
Yep, and even in the other direction it keeps going up, 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 up. Does this graph keep going down, 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 down?
No.
Does it stop somewhere? Yeah, where does it stop at? Yeah, at this -4. So I'm going to just kind of do that line there to show that it stops at that -4. So I want to show which y's this includes. It includes all the y's that are bigger or smaller than -4. Bigger, so greater than. Can it be equal to -4? Did it touch that -4?
Yeah.
Yep, so greater than or equal to -4. Meaning it doesn't go below that -4. It's stopping at that -4. Okay? Alright, I like to color code this next one too, so I'm going to do my orange going as my X, my domain. My range I did as blue today. So in our notes here, when it says left or right, question mark, up or down, I actually think about that as like left, 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 right, 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 up, 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 down, down, down. Okay, I like do it lots of ways. So for my domain, I'm going to think left and right. If I follow this graph and I go to the left, 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 does it keep going left, 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 or does it stop somewhere? How do I know it's stopping and not continuing to go? Because this one, you said it keeps going. There's no arrow, it stops. Good. And I'm looking left to right, so I'm looking at where does it stop on that x-axis. And this one it stops, yep, at -4. Okay, now I want to think to the right. As they go right, 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 does it stop somewhere or does it keep going?
It keeps going.
Keeps going. So I want the x's that are greater than or less than -4.
Greater than.
Yep, all these numbers on the x-axis that it covers is bigger than -4. So greater than, can it be equal to -4?
Yeah.
Yep, and or equal to -4. All right, and then for our y's, we're going to think up and down. Does this graph keep going up, up, up?
No.
No. Does it keep going down, down, down?
Yes.
Yeah. So it keeps going down, down, down. What's the highest up it goes?
2.
Yeah, the highest up it goes is this 2 right here. So 2 is going to be my boundary, saying it doesn't go past 2. Now this time, are the y's on that axis where that graph is, are those y's greater than 2 or less than 2?
Less than.
Less than. And it can have that or equal to today. We're not too worried about that or equal to right now, as this is our first time doing domain and range on a graph. All right, and this one's actually called the square root function, or sometimes called a radical or a rational function. We're going to work with those in just an I-5, I think, next week. Okay, we did parabolas already. What kind of graph is this one?
It's vertical.
Vertical means straight up and down. It's a positive slope. What do we just call that when it's straight? Starts with an L. Ends in ein. Oh, it's a line. Whoa. Tricky, I know, right? Okay, you guys are looking at me like I'm done. It's a line graph, or a linear graph, so it's a line. We've done these before back in Unit B. Again, we're going to look at our domain and our range. And most of the time with line graphs, our domain and range are the same, because as long as it has a positive or a negative slope, it's going to keep going on and on and on and on and on. So as I think left and right, does this graph keep going left, 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 left?
Yes.
Does it keep going right, 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 right?
Yes.
Yep. So what do you put if it goes in both directions all the way across?
All real numbers.
Good. All real numbers.
Who are you?
Have a good day.
Disrupting class.
Happy Valentine's Day.
No, that's interrupting our class.
All right, and then our range is going to go all the way up, 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 and all the way down, down, down. Does this line keep going up, up, up?
Yes.
Does it keep going down, down, down?
Yes.
So what is our range?
All real numbers.
All real numbers. Now, I'm going to give you a hint here on your homework. It's not really a hint. It's more or less just telling you it's okay. The graphs are probably going to be the hardest part on your practice work for your quick check today and for your practice on Thursday. Okay? So, it's okay to feel like you're getting frustrated with those graphs or you don't quite understand them. It takes a little while to get that hang